Hello everyone. Today we are going to learn about 2D translation computer graphics. So what is 2D translation? So 2D translation is basically a fundamental operation in computer graphics that involves moving object or points within a two-dimensional plane. It's basically if means a 2D object like triangle squares, we move it from one point or position to another on a plane. It's a core concept used in various graphic applications like game development and UI UX designing, etc. So moving forward, so understanding the translation process, first we describe the initial coordinates. Like if you are want to move a triangle, so you decide the initial coordinates of it, like x1, x2, x old y, sorry, x old y old. So after that, you decide the translation vectors named tx ty to determine the magnitude and direction of the movement. So tx specifies the horizontal shift and the ty represent vertical shift. Positive tx shows the movement in positive x direction, and negative tx shows the in left direction. Similarly, positive ty moves upward and negative ty moves downward. Now the new coordinate, to find the new coordinates, we will simply add x new equal to x old, means the original coordinate of that point, plus the tx we found or initialized. Same for the y new equal to y old plus ty. This is the result in the object being moved to its final position in 2D plane. Now visualizing 2D translation. So imagine a simple shape like a square or a triangle on a 2D plane. When you apply a translation vector, the shape move along the plane following the direction and magnitude defined by the vector. And the coordinate system, the translation process is based on a coordinate system, usually with x and y axis. The coordinate of the object represents its position relative to the origin of the coordinate system. And transformation. Translation is considered as a geometrical transformation, which means it changes an object position without affecting its shape or size. The object's orientation remain unchanged. Means if you want to move a triangle or a square, it will be moved without changing its shape or its area or anything. Moving to next. This is basically how you do the translation in matrix form. The translation equation can be represented more concise and effective way using matrix manipulation by introducing a third coordinate, say 1, or you can take it anything random value. Call it homogeneous coordinate. We can represent a 2D or a point as a 3D vector. So means if we give a point, three vertices or say xy and other constant, this will allow to express the translation as 3x matrix manipulation, providing a convenient way to handle and manipulate. So the practical application of 2D translation is in animation. Like in animation, 2D translation is fundamental for creating smooth and dynamic movements. By applying a series of translation over time, animator can bring characters and objects to life, creating a realistic or styled movements. So think you have seen in most of the animes, like a main character is fighting, so you can see that the movements, they are basically the part of it. Now in game development, like you play the games, there you see the movements of objects, like fighting the enemies, they are all made with this. And user interface design often employed 2D translation to position and move interactive elements like buttons, sliders, and menu. This ensures that the user can easily interact with interface by dragging, clicking, or selecting elements. So next is understanding homogeneous coordinate simply transformation. Simplifying transformations, the homogeneous coordinate enable a unified approach to representing points and vectors in a 2D This allows us to perform all geometrical transformations, translation, scaling, rotation using matrix manipulation, simplifying the overall process. Extending to 3D, the concept of homogeneous coordinates extends naturally through 3D graphics. In 3D, we introduce a fourth coordinate W to represent point and vectors, making it possible to perform 3D transformation using a matrices. This is a powerful technique for handling complex transformations in 3D space. Enhancing the flexibility, the homogeneous coordinates system provides increased flexibility in handling various geometrical transformations. It allows to combine different transformations including into a single matrix operation, making it easier to perform complex transformations in a single step. So, combining translations, concatenation. Multiple translations can be combined by multiplying their corresponding matrices together. This creates a single matrix that represents the overall transformation resulting for the sequence of translations. So, basically, you can merge all the translations you have performed on various shapes to create come on. You create a film type. And next, the order of operations. The order of matrix manipulation matters. Performing the translation in different orders will lead to different final positions. The matrix manipulation order determines the order in which the translation are applied. For example, multiplying T2 by T1 with result in applying T2 first and then T1. Efficiency. By combining translations into a single matrix, we can apply all the transformations simultaneously. This significantly improves efficiency, especially when dealing with complex graphics scenes involving multiple transformations. So, conclusion. Understanding 2D translation is essential for any professional working with computer graphics. It provides a fundamental tool for posing, moving, and animating objects in 2D environment. By mastering the concept of translation vectors, matrix representation, and homogeneous coordinates, you can efficiently manipulate objects and create compelling graphics experience. Thank you.